Learning objectives. At the end of this topic, you will be able to understand basic terms and definitions, illustrate intersecting lines and non-intersecting lines, illustrate pairs of angles. Introduction. In our daily life, we see different types of angles formed between the edges of plane surfaces. These are all some examples of lines and angles in our real life. Let's recall all the basic terms and definitions here. A line is a collection of points along a straight path. A line has no endpoints. A line can be extended indefinitely in both directions. Consider the line AB. It's denoted by a double-headed arrow. Sometimes, lines are also denoted by small letters L, M, N, etc. A part of a line with two endpoints is called a line segment. A line segment AB is denoted by AB bar. A part of a line with one endpoint is called a ray. The ray AB is denoted by a single-headed arrow. If three or more points lie on the same line, they're called collinear points. Otherwise, they're called non-collinear points. Consider the two rays AB and AC originating from the same endpoint A. This formation brings us to an important turn in geometry, the angle. The rays making an angle are called the arms of the angle. The point of the origin or the intersection is called the vertex of the angle. The size of an angle is measured in degrees. Let's quickly review different types of angles based on their measure. Consider a shape formed by two rays diverging from a point P. The angles formed here is 40 degrees. An angle measures less than 90 degrees but greater than 0 degree is called an acute angle. An angle measuring exactly equal to 90 degrees is called a right angle. An angle greater than 90 degrees but less than 180 degrees is called an obtuse angle. An angle measuring exactly equal to 180 degrees is known as a straight angle. An angle which is greater than 180 degrees but less than 360 degrees is called a reflex angle. Consider an angle ABC. Pass the ray BD through the vertex such that it divides the angle ABC into two. The two angles that are formed angle ABD and angle DBC. These angles have the same common arm BD and common vertex B. Two angles are said to be adjacent if they have a common arm and a common vertex. Now observe the adjacent angles ABD and DBC. Sum of these angles is equal to 180 degrees. Such a pair of angle is called a linear pair. Here the common arm is BD and the non-common arm BA and BC form a straight line AC. Consider the line AB and CD intersect at the point O. At the point of intersection, four angles are formed. On measuring the opposite angles, you will find out that they are equal. Such angles are known as vertically opposite angles. Two angles whose sum is 90 degrees are called complementary angles. Two angles whose sum is 180 degrees are called supplementary angles. Intersecting lines and non-intersecting lines. Draw two lines AB and CD in two different ways. You can see that the lines are intersecting in figure A, but the lines are not intersecting in figure B. Let's look at these set of lines crossing one another at a single point. Such lines are called intersecting lines. Intersecting lines can be defined as two or more lines that meet at one point. Now let's look at another set of lines. These lines never meet at any point. Such lines are called parallel lines. Parallel lines can be defined as lines on the same plane that never intersect. Two lines in the same plane are parallel if they are equidistant. These are some examples of parallel lines. Pair of angles. Here we learn about the relation between the angles formed when a ray stands on a line. Draw a figure in which a ray stands on a line. Name the line as AB and the ray as OC. The angles are formed here: angle AOC, angle COB, and angle AOB. Can we write angle AOC plus angle BOC is equal to angle AOB? Yes. We already know angle AOB is 180 degree since angle AOB is a straight line. So we can write angle AOC plus angle BOC is equal to 180 degrees. From this discussion, we can state the axiom: if a ray stands on a line, then the sum of two adjacent angles so formed is 180 degrees. Remember, when the sum of two adjacent angles is 180 degrees, then they are called a linear pair of angles. Now we assume the reverse concept of the previous axiom. Take the conclusion as given and the given as the conclusion. So it becomes, if the sum of two adjacent angles is 180 degrees, then a ray stands on a line. That is, the non-common arms form a line. But we do not know whether this statement is true or not. Now let's check it with different measures of adjacent angles. Keep the ruler along one of the non-common arms in each case. Here only in figure B, both the non-common arms lie along the ruler. That is, points A, O, and B lie on the same line and ray OC stands on it. Also see, angle AOC plus angle COB is equal to 45 degree plus 135 degree. That's equal to 180 degrees. From this we may conclude the statement: if the sum of two adjacent angles is 180 degrees, then a ray stands on a line. So we can state in the form of an axiom as: if the sum of two adjacent angles is 180 degrees, then the non-common arms of the angles form a line. The two axioms above together are called linear pair axiom. Now let's prove the theorem. If two lines intersect each other, then the vertically opposite angles are equal. In the statement of the theorem, it's given that two lines intersect each other. So we draw a line AB and CD intersecting at O. We have to prove angle AOC is equal to angle BOD and angle AOD is equal to angle BOC. In this figure, ray OA stands on line CD. Therefore, angle AOC plus angle AOD is equal to 180 degrees. From equation 1 and 2, we can write angle AOC plus angle AOD is equal to angle AOD plus angle BOD. This implies angle AOC is equal to angle BOD. Next, we need to prove that angle BOC is equal to angle AOD. Since AB is a line, thus the sum of angles AOD plus BOD is equal to 180 degrees. Similarly, CD is a line, therefore the sum of the angles BOC plus BOD is equal to 180 degrees. From equation 3 and 4, we can write angle AOD plus angle BOD is equal to angle BOC plus angle BOD. Therefore, angle AOD is equal to BOC. These are vertically opposite angles. Let's see a few example problems here. In the figure, OA and OB are opposite rays. If angle BOC is equal to 70 degree, find angle AOC. Since AB is a line, OA and OB are opposite rays, then angle AOC and angle BOC form a linear pair. Angle AOC plus angle BOC is equal to 180 degree. We know angle BOC is equal to 70 degree. Then angle AOC plus 70 degree is equal to 180 degree. On simplifying this, we get angle AOC is equal to 110 degrees. Consider the second example. In the figure, lines AB, CD, and EF intersect at O. Find the measures of angle AOE, angle EOD, angle BOD, and angle COF. Since line AB and EF intersect at O, therefore angle AOE is equal to angle BOF is equal to 35 degrees. Since angle AOE and angle BOF are vertically opposite angles. Again, since line AB and CD intersect at O, angle BOD is equal to angle AOC is equal to 30 degrees. Since angle BOD and AOC are vertically opposite angles. Now, angle AOC plus angle COF plus angle BOF is equal to 180 degree. Then substituting the angle of AOC and BOF. On simplifying, we get angle COF is equal to 115 degree. Again, angle COF and angle EOD are vertically opposite angles. Therefore, angle EOD is equal to 115 degree. Now let's see another example. In the given figure, find the value of y. By linear pair axiom, 5y plus 3y plus 2y is equal to 180 degree. On simplifying, we get 10y is equal to 180 degree. Therefore, y is equal to 18 degree. Summary. Let's summarize the topic. Two lines having only one point in common are called intersecting lines. If two lines intersect each other, then the vertically opposite angles are equal. Two lines drawn in a plane are parallel if they do not intersect even when they're produced. Distance between the parallel lines is the same. If a ray stands on a line, then the sum of the two adjacent angles so formed is 180 degree and vice versa. This property is called as the linear pair axiom.